Sir, the game is over, and the winning team decided they don't want to visit the president. They'd like to visit you instead.
This calls for tequila.
The finest tequila.
A strong tequila.
Hello?
Hi, it's Anne from Edward Jones.
I'm glad I caught you. Well, I'm just leaving the office, so for once I've got plenty of time. What's going on?
So, those financial regulations being talked about? They can affect your accounts. So let's get together and talk and make sure everything's clear.
Thanks. Yeah, that would be great.
We've grown to over $900 billion in assets under care by being proactive, not reactive. It's how Edward Jones makes sense of investing.
Rise to the future now, rise to the future now, rise to the future now, rise to the future now.
Rise to the future now, rise to the future now, rise to the future now, rise to the future now. Rise to the future now, 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 rise to the future now.
When you use Groupon in your neighborhood, you're not only saving money, you're also supporting local business. I mean, what kind of person wouldn't want to support local business?
I hate local business. Family owned, even better. Shut it down.
When you save in your neighborhood, it feels so good. It didn't feel good for him, though. Download the app and save. Groupon.
Sir, the game is over, and the winning team decided they don't want to visit the president.
Are they just not interested?
They'd like to visit you instead.
These scores for tequila.
The finest tequila.
A strong tequila.
Hell yeah. Hackathons. People work with.
Do hackathons?
Yeah.
Yeah.
Yeah. I used to do a lot of them, and now I just kind of burned out. And I'm slowly starting to do every single one of them. Plus, on top of that, it's like
I was actually thinking about hack other ones. You know any that happen like nearby or anything?
well, there's Hack Poly that's happening this weekend. Something's hacking CI. Oh, you know what? There's Caltech's hacking that's coming up.
I was kind of looking at like see what they're all about.
Oh yeah, they're fun. So I'm about to do, gonna do a video probably soon on my YouTube about what chapter.
Alright.
I think they undo.
It's just from the
Zelda's awesome. Zelda?
The game, alright? I wasn't calling him Zelda.
Yeah, I know.
Don't criticize that.
A lot of people are like, oh, Zelda, the dude with the sword. Like, yeah.
I remember I did that to my cousin when I was like 8 years old. I actually didn't know the difference at the time.
Yeah.
Now that's me whenever someone calls him Zelda.
Yeah. Or like if somebody calls Star Wars, Star Trek, it's like
Right.
just started seeing the last one. Pretty good.
You know, it also is pretty good not watching it.
Disney, you know, they did a decent job.
Oh yeah.
And they put in more comedy too, I think.
Oh yeah, Ryan Johnson had like full control over it, whereas like with J.J. Abrams, they wanted to play it safe because they weren't sure if it was going to do well.
So they put like a little bit of comedy. So it made it.
Well, they gave him pretty much full control over this. Oh yeah, that's the peak design that's the peak design capture clip. So essentially, when I take my camera off the the Joby Gorilla Pod thing, you can take it off. I can just clip it right on. I have two of those. So I have the V3 on my backpack, and then the V2 is on my Pro Pad, which is on my SMH pack. So I still use my backpack, but it's only for like whenever I gotta carry a lot of stuff.
Is this a mic?
Yeah. It has a dead cat on it, so basically it's real blend noise.
Are you streaming right now?
Yep.
So they
We're
can
live.
hear me?
So they can hear us?
Oh no, it's on our bumper.
Oh, okay.
There's like 3 people in the group together.
We have a huge internet right now.
Everybody just knows it's gonna be on YouTube, so they'll just watch it.
Or there's a lot of people just watching on there.
There's one watching right now, so shout out to the one person that's watching us right now, which I think it's probably me because I'm like previewing the whole thing.
Hey, same.
There's one person watching. Oh wait, I'm the one that's watching.
Good enough. Good enough.
Hey Sam, what's up, Andrew? Not much. Are you gonna do frisbee today?
I might. I didn't bring any shorts. I just remembered that it was.
I don't need shorts. Pants are fine.
Yeah, don't worry about it. Well, heck, you guys can just stand there and look pretty and throw it.
Heck, I'm planning on going too. I don't have any shorts.
No one else is wearing shorts.
No.
Well,
He
yeah,
is.
besides me.
I think.
Are you wearing shorts?
Yeah, I'm wearing
Shorts?
shorts.
Oh yeah. That's right. We'll be the cool people who didn't wear shorts.
Be the goalies.
Oh yeah.
Maybe they don't understand the importance of GitHub.
Yeah, people are just like, Git. What?
Yeah.
It's the first word, this word association. It's the first thing that comes to their mind is what?
Are these the papers from the cheat sheet? Cheat sheets?
I'll make a better one later, but this is directly from the GitHub.
I actually downloaded the Git Kraken thing. Will that still work the same too?
Oh yeah.
Yeah.
Git Kraken is awesome.
Just
But
making sure.
we're learning the command line to start off.
And, with the GitHub student pack, you can get 1 year of free Git Kraken Pro access.
Alright.
Which is pretty cool. I don't know really
don't know what it does.
Usually they like say, oh, you have a private repo. If you're making money off this, you need to buy our pro account.
Alright.
So Ryan,
Mhm.
last time did we have this mic, or is it new?
Oh no, we've had that mic, but I'm still trying to get to actually, recognize on the machine. But then I realize I don't have the right connector for it. So, yeah.
Because I remember it was pretty quiet last time. The video feed.
Yeah.
It'll improve over time though.
Yes, but I think I might need to get an adapter to plug that directly into here and get the audio from it. But right now I'm running audio off my headphones, like my earpod things. Of course, I'm gonna have to wait a while because I think I maxed out my card when I bought that. What is it? The flamethrower.
Yeah, from the boring company.
The boring flamethrower. I'm like, I wanted to get a Switch for my birthday, but fuck that. Now I'm gonna just get the flamethrower.
Maxed out my card, but worth it.
Exactly.
When is the expected delivery for that?
I think around sometime around my birthday, so April 1st. I'm like, sweet. I know exactly what I'm gonna light my cake with.
I saw a legislator initially the day after that got announced he used the bill to block all flamethrowers in California.
Seriously?
I was like, let him have it for like a year.
Yeah.
Let me have it for a week and then
I mean,
call
the amount of people that bought it isn't as big as.
That's
compared to,
honestly
like,
really
the whole
annoying.
population.
But I
The
can't
whole
believe
good,
it.
thing.
Yeah. What I can't believe is the fact that he's like, oh, well, we're gonna sell hats to help, start the boring company. And then they're like, well, if we run out of hats, we're gonna start just selling flamethrowers. And then they're like, we just ran out of selling hats. Guess we're starting with flamethrowers. And then they leaked the picture, and it was starting at $600. And then when it actually came out, it's like, no, it's $500. And I saw the total price with shipping and tax and all that. It's only $546. I'm like, buy it. Forget it. Yeah.
It should come with like.
They're shipping it with a
fuel,
fire
right?
extinguisher.
Oh, really?
Yeah, they're shipping it with the fire extinguisher that they're selling.
I mean,
I'm
that
like,
sounds about right.
sweet! So I got a fire extinguisher and a flamethrower.
That's good.
Yeah.
At least they're taking the proper precautions to say it's not our fault. We gave you the things to prevent.
Well, they're
the
gonna
fire
send you
fires.
like all the legal paperwork too.
That raises $1 million for them.
Yeah, like $3.5 million worth of flamethrowers or something like that. More than $3.5 million.
And I asked the other one. I asked that one to print
I'm
both
like-
sides, and it only printed one.
Yeah.
Guess
Maybe
it
it's,
depends on the PDF.
And I like to what
Fans
Elon
are
Musk posts
good.
on Twitter and everything. It's like, I would heavily suggest you guys, for your own safety, don't buy the flamethrower. And then his next tweet was, unless you like fun.
Yeah. Yeah, he's like, definitely a bad idea.
This is definitely a bad idea. Unless you don't like fun. Oh my gosh, I can't wait to see the UPS guy's face when he realizes what he's like shipping to my house.
And what is that?
What? Oh, you're touching yourself.
What?
Did you auto tab? Complete? Tab complete?
It's like the man page got printed out. It's doesn't exist anymore. Alright, cool. Alright, I guess we can. Hold on. think we're ready, man.
Yep.
Ready?
Live.
Welcome, everyone, to the CSE Club's weekly workshop series. We got Git today, and we're focusing on GitHub as our server. So today's presentation is titled Git-fu, because I like to think of Git as kind of learning the basics and then becoming a master at your craft. So there are people sometimes learn enough karate or kung fu to like be able to push and run, and people do the same thing with Git. They push and run. So I figure we'll learn how to be masters at our craft, and we'll maybe get a green belt or a yellow belt today. So let's see what happens. All right, and of course I put Bruce Lee quotes here. As you think, so you shall become. All right, so version control. What is that word in Git? What does that mean? Version control is a way of keeping your records, keeping them dated, having ways of rolling back when something doesn't happen or something wasn't correct or there was a bug that couldn't be fixed. You can fix it by going back in time and going back to a version of your code that was better, and it actually worked. And so Git, or version control, is a perfect way of managing a large project where there are many moving pieces and you need to quickly take out a piece and put it back to the previous version. Sort of like a Windows driver. And Git is a version control system. So Git was created, it's open source, and a little known fact is it's used to maintain the Linux core kernel. So everything that most Linux operating systems run off of, that Linux kernel is managed using the Git version control system. Alright, so how does Git work? So we've got a couple things, staging and commits. So when you start working on your files, it's usually the working directory is what we refer to it as. If you ever see the pwd command in Linux, it stands for print working directory. So it's very intuitive as to say, here's where you currently are, this is what you're working on. All the files that you're editing, those have been edited at least within the last couple hours or so, if you're constantly working on the project. But the moment you use the git add command, it adds it to the staging area, and so it's pretty much ready for version control. It's almost to that part. So you're staging it, getting it ready for version control so that it can be saved for future reference if you need to roll back. But it's not saved until the moment that you type git commit. So when you commit something, it fully becomes a Git repository. People call them repos for short. You can host a local repository, and you can keep control of your files there. But the cool thing is with programs like GitHub, or you're managing your own server, you can host things on the cloud, and so you can have version control on the cloud as well. So you can share it among multiple people, or you can, as I like to do, work from home and post my work up on GitHub and pull it down when I get to the computer science labs, and so forth. And so you have a life cycle here on the slides, as you can see. You start with untracked files. That's when you create a file, when you first start putting text into that file. And then you have unmodified. Unmodified is the state where it's being tracked, but there hasn't been a change made yet. So there's two different states of that. Untracked is where Git's not actively keeping control of the version. And if you deleted it, Git wouldn't care. But unmodified is where Git is caring about the file. So from there, you can edit the file, add stuff to it, take away stuff. Then it becomes modified. You can add it again, which stages it. And then when you commit it, it goes back to that unmodified state. So that unmodified state is kind of like your stable area. That's why it's marked in green. Untracked is red. It's not tracked at all by GitHub. If you removed the rest of the folder contents and you started another GitHub repo, that file would remain where it was at. And then when it's modified, those also show up in red as if they weren't tracked, because it's not until the change is committed that you're safe, that you have that version that you're working on. and then you can roll back from there if you need to. Alright, so there are a couple terms with version control. There's forking and branching. Especially with GitHub, you see this a lot. So forking is where you're taking somebody else's code and you say, oh, I think I could do that better, or I could add on to that. I have another feature in mind that I could do. So you take their code, you download it for yourself, you figure out how to run it, you figure out, okay, I could put my function in here somewhere. And then when you do that, you can submit a pull request to the owner, and the owner can say, they can look at it, they can say, I like that, it works, this code, I'd like to add that to my project. So they can approve the pull request, and then your code can become part of the big open source project that they're working on, much like the Linux core, Linux kernel core. Branching, on the other hand, is when you're part of a company or a group of people, and so you're internally working on the code together with a team. And so when you're taking somebody else's code and you're adding to it, you're making a branch off their code. So there's no pull request that's needed. You can directly pull the code as you need it and work on like a development branch or something. So you heard me talk about branches. Branches are a way of organizing your workflows in Git. Git makes this a lot of fun, especially when people have made open source tools that allow you to visualize these branches. This is kind of an artistic representation of what something might look like. But you see on each of on the left-hand side, you've got the vertical axis, and each of those is a branch. And then on the right-hand picture, you've got horizontal branches, and each of those lines represents a branch. So you can see the dots within that are kind of versions. So that's where the version control part of it goes. So as time goes by, usually you see the arrows pointing in the direction that time is going. So on the left-hand side, time is going down, whereas on the right-hand side, time is going to the right. So you usually don't put most of your code on the master branch. As I naively started out doing, I didn't have much on my programming project, so I just start out on the master branch and not have any other branches and just edit my code directly. But the master branch is kind of your production code, your release, whereas you could set up a development branch, and that's where most of the code would actually be worked on while people are saving their changes. And you could hide that from the public, so the public could only see the master branch, which is pretty cool. Within that, you've got like feature control branches and bug fixing branches, stuff like that. You can make a branch at any time that you want. Whatever your need is, whatever your company's organization policy is, or your group, whatever you decide to do, Git can organize it however you want for branches. Alright, so here are a couple workflows. As I stated, you can just have the master branch by itself. This is the simplest one, the easiest to set up because you don't have any branches at all to worry about. And then from then on, you can add more branches. So typical scenario, in this case, this picture has features as the branches, but you could have one feature branch and one development branch. The basic workflow is limited, so just the master branch by itself, you're kind of limited as to if everybody's working on the same branch, there will be a lot of conflicts, like people are changing code here and there, so code is going to be different, so there's going to be a lot of conflicts. When you break it into features, somebody can change a feature slightly and be working on that portion while the main code itself could be developed on the master branch, and then the feature could be put in later. Now, this is like the standard Git flow work idea, and you notice I had talked about the development branch being in there. So as long as you have a master for your production code, a development branch for your working code, and then features for when you want to add things or bugs. If you at least have this, this concept was created by Vincent Dreisen back in 2010 when Git was really getting popular. And as long as you have at least this concept of these branches, where features are on their own branch, and you have a public and a kind of a private development branch, you're good to go. Alright, so that's a quick introduction to Git and version control, so I want to get you guys started. So if you can, log into your Linux computer, and we'll get started with the project. Alright, so I'll let you guys get logged in, and I'll read through the instructions, but you guys can go at your own pace. And I'll follow up and go through all the steps after I give you guys a couple minutes. And go ahead and enjoy the memes as well. Yeah, the git push force is the one where you overwrite everybody else's changes to your benefit and everybody else's chagrin. It's a good word. I myself have had to overwrite my own commits because I made mistakes several times. It's a learning process, just like Kung Fu or karate. You have to practice the little things over and over and over again until it becomes second nature to you. Why would you want to use the Git console on the command line? Well, if you're ever in a position where you don't have access to a graphical user interface, where you have to be SSH'd in somewhere, it's a great opportunity to use that, especially if the company that you're working for, their policy is you can only do command line for whatever reason that is. It's just good to have on hand just in case. Yeah, just open up the terminal, sorry. And once you're logged into the school terminal, you can, I'm in my home directory right now. So the first instruction here was, or the second one is make a directory and then change into that directory. The first one is also, if you don't have a GitHub account, I would really consider making one. So I have a GitHub account here, and you can see my account right there. You can see all my Git stuff that I posted over the years and months. The parts where it gets really heavy is when I was saving my coursework online so that I could jump between my home computer and the lab computers here. Yeah, so does anybody not have a GitHub account? Yeah, okay. So it should only take like a couple minutes to make it. Yep. Yeah, you wanna, and I'll make one right now as well. So I'm gonna call mine. What should I call it? I'll call it Git-fu, because that's the name of the workshop. All right, it starts out blank, as you can see. Alright, and then the way to start a Git repository locally is just to hit git init. And what that does is if I ls all, it gives me a .git folder. Let's see what's inside there. Okay, so inside that hidden Git folder, which is why it starts with a dot, it's hidden. So it doesn't show up with a regular list command. You've got branches it keeps control of. You have a config option. You have a description and a head. The head is like your main branch that you work on. You've got hooks and info and references and objects, and all of that is kind of stored together to keep control of your entire source code repository. So everything you find in there, it's pretty empty right now, I think. Like if I look in hooks, yeah, there's only sample stuff in here. It's not actually helpful stuff. Yeah, info is just empty. Objects has some stuff in it. References. And the way that Git keeps track of your files is it makes a file hash of it. And it compares the hashes together, and if something's entirely different, then it figures out what's the difference between those files. If not, it just leaves it alone and says, hey, this hasn't changed at all. So it just moves it on to the next commit. Yeah. So the next step is, create a README file. You can use your favorite text editor. I love using VI, but on the Linux tools, there's also the text editor software program. Or if you're feeling really ambitious, you can pull up the open source Visual Studio. Any of those work. So I'm just going to hit vi, and you call it readme. It doesn't really matter what you call it, but readme.md, the MD stands for Markdown, which is another kind of text language that allows for easy formatting. So one hash mark means the header 1 tag in HTML code. So if I type a sample readme file for my Git repo, and then I can type just a regular paragraph, and this will show up as nicely formatted paragraph text. So I can say this is some sample text for effect. Cool. Alright, so what's the next step? Don't forget to introduce yourself. So if you see on your cheat sheet, there's a git config option. Now what you want to do here is, this will set up kind of your authorship of files. You don't have to do this, but it's nice for people to know who edited what file. So if I hit global, that'll set it for the entire Git, kind of the entire Git system on the entire computer. If I just do local, yeah. Yes, sorry about that. I always forget about that part. Alright, git config. I could do global, and that'll set it for my entire user account. Or I can just do without the global, and I can do user.name, and I can specify my name in quotes. And you can put your full name or your actual GitHub username, whichever is better for you. And then you can do the same thing for user.email. And then I can set like my school email. Yeah, there you go. Yeah, so my global stuff is kind of different, you can see from the local. So my global, I'd set my email as my personal email, whereas the local folder, I'd set it as my school email. So just some cool settings you can put in there. There's also the UI color that you can set as well. A bunch of config options. And you can also do git help. If you don't understand something, you can type git help and then that command name, and it'll show you like all the config options that you can choose. So let me see if I can find some. You can set up your entire environment. They give you examples of what to do. You can choose like a diff algorithm. So when Git's looking at the difference between two files and you say git diff, it'll be able. You can choose the algorithm that you want that to call. You can even set up a proxy, which is important if you're behind a proxy server. Yeah, some pretty cool stuff to configure that as you want. Alright, so the next step is start tracking and commit your changes. So let's see what's going on. So with git status, you can see what the state of it is. So it says no commits yet, and there's some untracked files, and it's in red. So it says that readme.md, which we just created, is untracked. And it gives you a hint. So you can say git add, and then file name. The file in the brackets means that you can specify that readme. So you can say git add. I could type readme.md, or I could say dot to say everything in the folder. So let's try that. Alright, so if we do a git status, try it again, you can see it's green. And so it says no commits yet, changes to be committed. So it hasn't been committed yet. So remember that difference between staging and committing. So we were in our working directory, then we did the git add command that puts in our staging area. So we're here right now. The last thing we have to do is call the git commit. Alright, so let's look. So it says git commit -m, and that stands for making your own message. So I'll clear and I'll say git commit -m, and then you can put your message in quotes. And so I'll say this is my first Git-fu lesson. Cool. Alright, and so we get some messages. So it says 1 file changed and 3 insertions. And it also shows like the file permissions mode with the create mode. So if we do a git status again, you can see nothing to commit, your working tree is clean. So that's usually what you want to see. If you have some executables and stuff, you could also create a .gitignore file. So you just type it just like that. And then in here you could put, I want to ignore everything that ends in .exe, or I want to ignore everything that ends in .o, for instance, if you're compiling C++ objects. Yeah, that'll do for now. If you didn't want to include your .gitignore, you could actually ignore your .gitignore. And so if you had stuff in your .gitignore that you didn't want to be put up there, then you could ignore it, and it wouldn't put itself up there, which is fascinating. So I'll leave that there. You'll see if I do a git status again, it also says, hey, that's also an untracked file. So I'll do a git add with a dot, and I'll say git commit, and then I'll say for my message, I'll say also added, and this is just to help you remember and to maybe help others when they read the history of commits to see what actually happened. So that's why these messages are important. So I also added a .git ignore file to be thorough. And you can think of these as like short Twitter messages, so keep them under 140 characters and you'll be good to go. Alright, cool. One more git status and I can see what's going on. Very cool. Alright, so yeah, I did that. You don't have to. It's just for demonstration purpose. So if I had made a, so I'm just going to call it a .o. It's actually going to be a text file, but if I say sample.o and I put some gibberish in here, I wouldn't want to include that. So if I do a git status, it actually says, hey, your working tree is clean, although there's a brand new file in there. So because of that .o, the git ignore file causes Git to ignore that file. So pretty intuitive. You can use that to your advantage. You can actually disregard entire directories. So if you have like an executable directory or like a binary directory, you can put all of your binary and executable compiled files in there and just exclude everything in that directory. And that would look like this. You just add that into your git ignore and then exclude everything in there, or exe, something like that. So yeah, definitely use that to your advantage. Alright, let's see what's next. Oh yeah, step 1, we actually, not only do we need to create an account, we need to create a Git repository. So, I'm just going to hit my home page right here for GitHub. And, once it loads, there's a green new repository button. Alright, I'm going to call this one Git-fu as well. Put a description, a sample, Git repository. And because I have signed up for the GitHub Student Developer Pack, I get free private repositories. If you guys would like to visit that, just look it up. And it's the first link that you get. So you can sign up with your school ID and you get all kinds of cool free stuff. So DigitalOcean, $50 in DigitalOcean hosting, unlimited private repositories, which are normally $7 a month, full Git Kraken Pro usage, Microsoft Imagine Azure stuff, Namecheap hosting, get your SSL certificate. So you can see there's like a whole bunch of cool stuff here. A lot of cloud development stuff. You get the complete Unreal Engine suite, like everything that you could ever want. And you just have to click Get Your Pack, and it says, hey, check in with GitHub. And of course, I'm already logged in, so it says I have all of this stuff. Yeah, and you can just click request your stuff, and hey, you get some awesome stuff like AWS credits for a total of between $75 and $150 worth of web hosting space. That's a deal right there. Yeah, educate stuff. Yeah. So, yep, Bitnami cloud application. All right, so that's why I'm allowed to do the private repositories. It would tell you they would cost money if you didn't have that. So because I've signed up for the GitHub Student Developer Pack, I have unlimited private repositories, at least until I'm not a student. So at which point I'll have to get rid of those. Alright, so I've already initialized it with the README, so I'm not going to check that. And I have a git ignore. You'll notice it gives you options for cool things that you can do, so you can, it's kind of down there, sorry. But there's a C++ git ignore, there's a C makefile, PHP, Drupal, Fortran, Go, Haskell, Java. So you can see there's pretty much everything that you could ever think of, there's a git ignore file for. And you can add a license, so if you're worrying about which license should I include, you can choose the MIT license, which is widely used, or BSD or the GNU licenses. But that's about it, just the name and the description, and you can create it. And then it says, hey, you've got an empty repository, so put some stuff in it. Alright, so let's use the HTTPS should be fine. So you can pull from it, and we'll copy. Yeah, I think this link should work. We'll try it. So the way to add this in, I have the help file here, is to add this remote repository, we say git remote add, and then you give it a name. So a common name that you see a lot of times on forums and stuff is origin. So this is a very intuitive name because this is where your repo spawns from, so it's like it's your repo's origin. You could also call it begin, yeah. Let's do that. We'll have some fun with it. So just know that wherever it would say origin, you would say begin. And then you can put the repo that you copied. And I copied that repo from the link here at the top.
Right click.
Yeah, right click. Yeah, usually the best way to get there. Unless you know the shortcut keys. or shift insert. Something like that. Alright, so I'm going to add the remote. And so to check that, which I also have up here, you can do git remote -b. And that'll show you, hey, you set up this repository for fetching and pushing, which is cool. So let's try it, shall we? Let's do a git push. Yeah, let me know when you guys have it set up. Anybody lost? Yeah. So git remote admin, put some sort of name, begin or origin. Alright, I think we're ready. Alright, so we'll do this command. So it's git push -- set upstream, and then you have the name and then the branch. So I'll show you how I came up with that command. So the first thing I tried was a git push, and it tells you no confirmed push destination. So it gives me some hints. So I can say git remote add name URL, which we just did, or push the name. So let's git push and then begin, because that's what our name was. Alright, I'll try it again so you guys can see it's getting down there. Alright, so it says fatal error, the current branch master has no upstream branch. Upstream branch is kind of like it's a Git phrase saying upstream as in further down the line, you know, the next commit that you're going to make. We need something to reference. So let's give it a reference point. So it tells us the command right there. You can see it's pretty much the same command that I have here. I just changed it to reflect the name. So if we do git push, set upstream, and you can tab complete, it'll help you type faster. You can do begin and then the master branch. So you always start with the master branch for everything. And then it asks you for your username, and I'll type mine, and you will type yours, and then your password. So make sure that you remembered it. Don't worry, we'll fix this part so that you don't have to type your password anymore. Alright, my authentication's not working. Why? I actually came across this problem last time. Anybody else having this problem? Yeah, I'm actually going to do, I'm going to change my remote to do SSH instead, because my SSH stuff is set up. Let me know if you guys are having trouble with this though. I think it's with HTTP. I'm trying to guess. Oh yeah, I don't need the. Yeah, I just need the. Alright, it says remote already exists, so I'm going to try to remove it. And I don't remember what that command is, so I'm going to do help remote. And it says I can remove with the name. Alright, so git remote remove. And then we called it begin. And then I'll do git remote add begin, and then git at github.com. Alright, so did anybody else successfully do the HTTP? Okay, cool. I think it's because I'd already previously set some SSH stuff that it doesn't want me to do that. So let's try that git push set upstream command. Fascinating. Oh, I see. Yeah, I forgot the colon. Alright, let's try it one more time. Alright, so it should work now. So I'll hit the set upstream and begin master. Cool, that's a good sign. So mine didn't ask me for username and password, but I'll show you guys how to set that up. Alright, so it says there's a new branch, which is master. So if I do git branch, I can check what branch I'm in. And it says master. So master is like the default branch, as we looked at in the previous slides. We have this master branch here, so same thing. So that's kind of your default branch that you start with. Alright, now let's check it out online and see what happens when we refresh the page. So you guys should see that your README file shows up. Anybody not see that? Alright. Pretty cool so far, right? Alright, so let's go on to the next slide. So this one, we're going to get some branching in. Alright, so you want to create a new branch with whatever name you like. So it could be development. So git branch, and then a good name for a branch would be, let's say I want to, since we're doing Git-fu, I want to work on my roundhouse kick. I'm going to call it roundhouse. Now if I do git branch, you'll see roundhouse has been added to the list, but I'm still on the master, as you can see with the asterisk. Alright. Alright, so we can move to that branch by doing checkout. So if you ever hear the word checkout, this is what they're saying. So it's saying git checkout roundhouse. If you do git branch again, cool. So you can see we moved from the master branch to the roundhouse branch. Alright, now this is where it gets into the magic of Git. So let's add a file. So I'm going to call it howtokick.txt. I'm going to say step 1, lift your leg. Step 2, kick. Alright. And we'll do a git status, so you can check if there's anything that needs to be added. Oh, what do you know? That file that we just added needs to be added. Alright, so we'll do git add, and then we can do dot, and it'll add everything in there. Yeah. Cool. And if we do a git commit, we give it a message that says added instructions on how to kick. Cool. Alright, so this is committed on the local repository, but we have to add the changes here. As you'll see, no matter how many times we refresh this page, there's still only the branch master. So we have to update that to the remote repository. So just like we did with that set upstream command, we don't need the set upstream anymore because that's been started off already. And we don't want master because we're on the roundhouse branch. Okay? So all it takes is git push, then the name of the remote repository, and then the name of the branch that you want to push. So if I say enter here, it'll ask you for your username and password again. In the case of mine, I've already set it up so it doesn't. And it tells you, hey look, you got a new branch now. So it's been set up to roundhouse, so if we look and refresh the page, you should see a new branch that says roundhouse. Now remember we put that new file in the roundhouse branch, and you'll notice that master doesn't have that file. So if we go to the roundhouse branch, that file shows up. The same thing on our local directory. So if we do an ls, that howtokick.txt file shows up. But if I do git checkout, and then I do master, so I've switched back to the master branch. I can check that with git branch. See, so I'm on the master. Now if I do another ls, that howtokick file is gone. Kind of weird, right? So Git has control of your files and how they show up. So if you're ever wondering, oh, where's that file that I created? Make sure that you check all your branches first and make sure it wasn't just created in one branch. Alright, so you could copy the file and then switch to a branch and then copy the file back into a branch. But there's an easier way to do that with the git merge. Alright, so what you want to do is switch back to that original, to the master, because we don't have that file in master and we want to put that file in master, okay? We figure that's a good general text file to have, instructional. So yeah, just double check that you're in that master branch with the git branch command, which we should be. And then you can say git merge, and then all that you need to say after that is the name of the branch. So we'll say roundhouse. And it says it fast forwarded, so it's moved up to the level that roundhouse was at, which is it added the how to kick file. Alright, so if you do an ls, there you go. You have that how to kick in there. And if we go back to our git repository, we can look at that master branch again. So it hasn't been refreshed yet, but the moment we do refresh, oh yeah, what did I forget? So we have the file in the local directory, right? But we forgot to push. Alright, so just make sure that you git push and then the name of the repository and master. And your username and password again. Cool. That username and password thing's getting kind of annoying, huh? We'll fix it. Alright, so that howtokick.txt file shows up, and cool, it's got all the text that we need. Alright, so everybody got a good handle on branching? Or at least the basics of it. Cool. Alright, so let's say we want to rename it, right? Because roundhouse is too specific, so let's say we just want a general kicking branch, alright? So we could do git branch, and then just like in Linux, you use the mb command to move, you can use -m to rename a file by moving it. Or renaming a branch by moving it. So we'll grab the roundhouse branch and we'll just call it kick. Or yeah. Or call it kicks. Plural. Alright, so no errors, that's good. Now let's do a git branch and see what it looks like. Cool. Alright, so it's updated on our local machine, but we have to push it to the repository, right? So we do git push, and then begin is the name, and then we wanted kicks was the name of that new branch, right? So let's do that. Cool. Told us there's a new branch, so let's go take a look. Cool, and it shows up. Alright, but there's one thing. The roundhouse branch is still there. So we gotta figure out how to get rid of it, right? Well, it's not too hard. We've got this special command as part of the branching that allows us to delete a branch. Actually, I take that back. It's not part of the branch command, it's part of the push. So git push, and we can delete with the -d, and then the begin repository and the roundhouse branch. So if we do that, it tells us it's been deleted. So now we should be able to refresh the page and see that, yep, there's no more roundhouse there. So I'm pretty sure though that it stays around at least to some point. You can at least reference it, but we'll see. I haven't done too much research on finding a deleted branch. Alright, let's see what's next. So, oops. Alright, so we've deleted the branch, we've renamed a branch, so we're kind of familiar with the branching concept, so you have complete control over what branches you have. Alright, so let's try some of that SSH key stuff. Alright, so this is where you don't have to type your username and password once you get it set up. So using the command line is the easiest way to generate an SSH key. So SSH is that tunneling protocol that lets you kind of encrypt your data and transmit it securely from one place to another. In this case, from your local machine to the GitHub server and back again. So using the SSH tunnel, you can pull data in and push data out. So it's a very secure way of doing stuff. So there's a way to generate these keys on Linux. So if you do SSH-keygen, this is a special command that when given the option of -t, you can choose an RSA encryption. It's the most common. And it's a type of algorithm for generating encryption files and numbers. So this is, you're getting into public and private key encryption territory right now. So you encrypt something with your public key, or your private key, and then the server uses your public key to decrypt it. The server sends you back data by encrypting it with your public key, and then you decrypt it with your private key. So your private key always stays with you, and you can hand out your public key to whoever you want. Alright, so we give it a type of RSA. The RSA is the three last names of the mathematicians who invented this. And then if you do -b, you can tell it how many bits you want. 2048 is usually one of the better encryption numbers. It's a lot more than 1024, and it's not too much like 4096. So 2048 is a good number. You can give it a file name, but let's just keep it pretty simple, and let's just keep it as it is. I've already generated mine, so I don't want to overwrite it. No, actually, I renamed it, so it's safe for me to create a new one. So if I hit enter, it's going to tell me generating it and enter the file in which to save the key. So you can again specify the file name here. By default, it's going to place it in your home directory under the .sh, so the hidden SSH file. It's going to call it ID_RSA. That's kind of like the default name for your RSA key that you generate. And when you install OpenSSH, it actually generates one for you automatically the moment you install the software on Linux. So I'll just hit enter because I'm happy with that. If you want a passphrase, which what I suggest is you don't really need it because you need a passphrase to enter your computer. So as long as you're pretty certain nobody's going to be entering your computer, we'll keep it easy for ourselves and not have to enter a passphrase. So you can just hit enter and skip all of that. It gives you a nice little picture printout of what your key would look like in ASCII. You know, it's kind of helpful, at least for the artwork part of it. So we have our key file, and I said something about the public and private key, right? So let's cd into our home directory. Or you don't have to cd. You can at least SSH to see what's in there. So yeah, ls to see what's in there. Too many words going on in my mind. All right, so you ls into SSH and you look. I have a couple. I've generated a couple private and public keys, so you can see I've named a bunch of them. But at the bottom here, you've got this ID RSA. I've created some backups of my old keys. And then you have the ID RSA.pub. So the one without the .pub is your private key. That's the one that you keep to yourself and you never show anybody. The public one is the one that you're allowed to say, hey, you can take this and use it, encrypt files for me, and then I can decrypt it with my private key. So if you want to cat out that file, so we'll use the catted out public key. Make sure that it's the public one, so it's the .pub. So if you cat that out, you see it's a long string of stuff. And at the end, it's got like my username, which is actually the comment for that. So you could set your own comment later. You could even edit that file and put your own comment there. That part doesn't matter. The only part that matters is that this string, you can copy it now. We'll save it for later. Forget the right click like pastes, at least on the putty. browser. Alright, so if you copy that, we can use that to make our login process easier on SSH. So if I go to my profile picture up here in the top right on GitHub, and I click Settings, I can go over to this left menu over here and click SSH and GPG keys. You'll notice I've set up a lot of keys, right? So I have my laptop here that I'm using right now, and I have my first CSE lab key that I made, the one that I commented out with the dot back, and then the one that I made last night, and then I can make another one right now. So I can call this CSE Git-fu example. And then you'll just paste your key. So make sure it begins with that SSH RSA that tells GitHub what type of encryption algorithm you're using, and then paste the entire key. I think there's a space here, so I'm just going to delete that. So the only space you should have is between the encryption name and the key itself. So you should be able to add it. If you did it wrong, it would give you an error. I'm going to just type my password in real quick. So this is where the security part of it comes into play. GitHub puts you through a lot of loopholes to make sure you're not a robot and you're not doing this autonomously, which is good. And you'll notice that I now have that key enabled. I can delete them whenever I want, so if anybody ever gets access to one of my private keys, I can just make another one, put up my public key here, and delete that immediately. No one will be able to access my stuff without my permission. Cool, huh? You can also do GPG, which is the GNU Privacy Guard, or the pretty good privacy standard, like OpenPGP, if you've ever heard of that, for like email encryption. You can also use that to access it. And I think that one works over HTTPS. So I'd be curious if anybody figured out how to do that. Cool. So once you have that set up, there's just one more step. Cool. And make sure you're back in your Git-fu directory, or whichever directory you created for the repository. And you want to remove, remember that remote repository we added? So you want to remove that. So we'll remove begin, and then we'll add it again. So git remote add begin, and we'll use the different URL this time. So let's find our repository on GitHub again. So I have that Git-fu, and then there should be a clone or download button, and let's clone it with SSH. So let's take that link. That's our SSH one, so we can use our SSH keys on that. So I'm going to paste that in there, and it should update, and we can see it with git remote and verify. Cool, so now we can use fetch and push. So if you guys want to edit the sentence in that how to kick file, I could say step 2 is to breathe. Focus. I think there's an E at the end. Isn't there? Alright, and I'll save the file. I'll do git add dot to add everything. Git commit. Added the most important instruction of all. What did I forget? Oh, cool. Alright, and let's do a git push. And then the name of the repository should still be begin if you kept it that. And then we'll say master. I think we're still on the master branch. Awesome. And it shouldn't ask you for a password. It should just work because GitHub searches for the default ID RSA key. So that's what it's looking for. So we have that file already, so it should be Perfect. I've actually set it up to use a different file, and I'll show you guys that in a minute. But I think we did, yeah. Okay, alright. I wonder why. Yeah, so many variables to check out. Yeah, I think that was, that's what I had for that. Yeah, it's about 440. So I don't know if it's maybe the first time that it asks you for your username and password just to make sure that it's you. The second time it might not ask you for your password. But I've been doing it for a while, so I think it trusts me by now. I'm not sure. Maybe. Yeah, if you guys are still having trouble with it and it still asks you for your username and password, let me know, and I'll do some research and I'll figure it out. If you guys watching online are curious about how to do that, just send us an email if it's not working for you, and we'll figure it out. Cool. So I'm going to look at I have a config in the SSH directory. I just set this up this morning because I was curious to see how do I set up a different key name to use by default. So it's actually here where you can specify which one you want. And I think it actually overrode it, so it wasn't actually using the ID RSA that I was using because I already set it to force it to use this one. So it was already using the one that I made last night. So this is a setting as well. If you'd like access to it, I'll pause for a moment to let you guys look at it. If you want, you can check out the YouTube video, rewind, look at it again. Cool. Alright, any questions? That's the command line version. So there's also Source Tree by Atlassian, the creators of Bitbucket. You have the GitHub desktop and Axosoft's Git Kraken. So those are the three common Git GUIs, graphical user interfaces. So this allows you to just point and click, and within 5 minutes you have your repository set up. You can link these with IDEs, which is what Andrew's going to talk about next week in next week's workshop. But for instance, I have Git Kraken installed on my computer. Takes a little bit to get set up because it's a pretty beefy application, but it's worth it. It's not as heavy as Visual Studio, but when you got a lot of RAM being sucked up by Chrome, it takes a little bit to get started. You can also put your SSH keys in to Git Kraken, and so it won't ask you for your username and password every time you want to do a push or a pull. And Git Kraken is probably the best mascot that I've ever seen. Wouldn't you love to be the guy coding that animation? So because of the GitHub Student Developer Pack, I get the Pro version, so I can also do private repositories with this. I haven't signed in a while, just because I haven't been using it. But you can sign in with GitHub, so as long as you have your GitHub account, it's versatile. You can use it a lot of places. Pulls up the web page and logs me in. Cool. It's got a very simple website. It's pretty cool. It's free to download. You just can't do private repositories. Alright, so I want to clone a repository. Actually open one because I already have it. No, I don't have it saved locally. So this is on my local computer. I could clone it with the URL. Could tell it where I want the local file to look at. and I'll put it here. Call it Git-fu. Actually, no, I'll just do this. Yeah. Alright, I'll select the GitHub folder so it puts it in there. And then that same URL, I think I still have it copied. Yeah. Cool. And it gives me that folder name automatically. So I can clone the repo. It should work. Cool. I can open it now. Bam. And so it has my entire history of my commits. You'll see the other one I was working on for my 455 class. That one's a lot more active, a lot more branching going on, because we had a lot of fun with that. But yeah, the Git-fu one's pretty simple. A lot of stuff on the master branch. And then we had that that kicks branch come off of there. So you can see the entire history. These GUI applications are perfect for that. And then you also have your settings here. You can manage your account. Actually, no. I think it's keys are somewhere around here. Preferences, maybe. Yeah. So I can do authentication. So you can see you can authenticate with just any SSH key or your GitHub specific account. GitHub Enterprise, GitLab, GitLab Self-Hosted, and Bitbucket. So those are the most common online cloud services. All right, any questions, guys?